In this episode, we move into security architecture by looking at where systems live and how that choice changes security responsibility. Architecture is the design of the environment that supports applications, data, users, networks, and security controls. You can place systems in your own building, in a cloud provider's environment, or across a mix of both. You can use services shared with many customers, services reserved for one organization, or services shared by a specific community with similar needs. These choices are not only technical. They affect cost, control, risk, staffing, recovery, visibility, and the way security work is divided. When you hear cloud, on-premises, hybrid, private cloud, public cloud, or community cloud, do not treat them as marketing labels. Treat them as different operating models. Each one answers the same basic questions in a different way. Who owns the equipment? Who controls the configuration? Who protects the data? And who is accountable when something fails? Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.Me in the Bare Metal Study Guide series. An on-premises environment is one where the organization runs systems and facilities it owns, leases, or directly controls. The servers may sit in a data center, office server room, manufacturing site, hospital, school, or government facility. The organization is responsible for the building space, power, cooling, hardware, network equipment, physical security, software platforms, backups, monitoring, and many day-to-day operations. That level of control can be valuable. You may have strict requirements about where data must stay, which people can touch equipment, what network paths are allowed, or how systems must be maintained. On-premises architecture can also support specialized equipment that does not fit easily into cloud services. The trade-off is responsibility. If hardware fails, the organization must replace it. If capacity runs out, the organization must buy and install more. If patches are delayed, monitoring is weak, or backups fail, there may be no provider to blame. Cloud computing changes that model by letting an organization use computing services delivered by a provider over a network. Instead of buying every server and managing every layer alone, the organization consumes services from a cloud provider. Those services may include processing power, storage, databases, applications, identity tools, analytics, networking, and security features. Cloud can feel flexible because resources can often be added or reduced more quickly than traditional hardware. It can also shift some responsibilities to the provider, especially for physical facilities, underlying hardware, and parts of the platform. That does not mean security disappears for the customer. The customer still has to configure services correctly, manage identities, protect data, monitor activity, understand exposure, and follow policy. Cloud security depends on knowing which responsibilities moved to the provider and which responsibilities stayed with the organization. The shared responsibility model is one of the most important cloud ideas to keep in mind. In a cloud environment, the provider and the customer both have security duties, but they do not protect the same things in the same way. The provider usually protects the physical data centers, core infrastructure, and services it operates. The customer usually protects its accounts, data, identities, access decisions, configurations, workloads, and how the services are used. The exact split depends on the kind of service. A hosted application gives the customer less control over the underlying platform, but still requires careful user and data management. A rented virtual server gives the customer more operating system and application responsibility. A managed database may shift patching and maintenance to the provider, but the customer still controls who can access the data. Security mistakes often happen when people assume someone else is handling a control. Public cloud is a cloud model where a provider offers services to many separate customers using shared infrastructure. The customers are logically separated, even though the underlying provider environment supports many organizations. Public cloud is common because it offers speed, scale, broad service options, and flexible consumption. You can provision storage, computing, identity features, and manage services without building a physical data center first. For security, The major benefit is that large providers often invest heavily in physical protection, resilience, specialized staff, and security tooling. The risk is that the customer can still make dangerous mistakes. A storage bucket can be exposed. An identity role can be too broad. A network rule can be opened too widely. Sensitive data can be placed in the wrong region. Public cloud reduces some burdens, but it also demands strong configuration management and clear understanding of provider-specific controls. Private cloud is designed for one organization rather than many unrelated customers. It may be hosted in the organization's own facility or operated by a provider, but the key idea is dedicated use. Private cloud can offer some cloud-like benefits, such as resource pooling, self-service, automation, and flexible allocation, while giving the organization more control over isolation, governance, customization, and compliance. This can be attractive when data sensitivity, regulatory expectations, or mission requirements make a fully shared model less comfortable. Private cloud is not automatically more secure just because it is private. It still needs strong identity controls, patching, monitoring, network design, backup, and operational discipline. It may also cost more and require more internal expertise. The security value depends on whether the organization uses the added control well. More control can reduce some risks, but it also means more responsibility for getting the design right. A hybrid environment combines on-premises systems with cloud services. Many real organizations are hybrid because they already have existing data centers, legacy applications, local networks, and specialized systems, while also adopting cloud for new workloads or flexible capacity. Hybrid architecture can make sense when some data or applications must remain local, while other services benefit from cloud scale or accessibility. It can also support gradual migration instead of moving everything at once. The security challenge is that hybrid environments create more connections and more places where assumptions can break. Identity may span both local and cloud systems. Data may move between environments. Logs may be stored in different tools. Network paths may be more complex. A weakness in one side can affect the other. Hybrid security depends on consistent policy, clear boundaries, strong identity integration, and visibility across the whole environment. Community cloud is a model shared by organizations with common requirements, missions, regulations, or security needs. You might see this idea among government agencies, healthcare organizations, research institutions, financial groups, or other sectors that need similar controls. The goal is to provide shared cloud services that are more tailored than a broad public cloud environment, but not completely separate for each organization like a private cloud. Community cloud can support common compliance expectations, shared governance, and services designed for a specific kind of user. The trade-off is that shared community requirements may not perfectly match every participant. Security still depends on access control, segmentation, data handling, provider management, and clear agreements about responsibility. A community model can reduce duplication and improve consistency, but it does not remove the need to understand who manages each layer and how each organization's data is protected. Ownership is one of the first questions to ask when comparing architecture models. In an on-premises environment, the organization usually owns or directly controls much of the hardware and facility responsibility. In public cloud, the provider owns the underlying infrastructure and the customer uses services built on top of it. In private cloud, ownership can vary, but the environment is dedicated to one organization. In hybrid architecture, ownership may be split across internal facilities and cloud providers. Ownership affects security because it affects who can change systems, who can inspect them, who must maintain them, and who pays when they need to grow or recover. If you own the equipment, you can often customize more deeply, but you also carry the maintenance burden. If you consume a provider service, you may move faster, but you must accept the provider's boundaries and operate inside their control model. Control is closely related to ownership, but it is not exactly the same thing. You may not own a cloud provider's hardware, yet you may still control many important security settings inside your cloud account. You may own an on-premises server, yet outsource management to another company and lose direct operational control. Security architecture depends on knowing the real control points. Who can create accounts? Who can change network exposure? Who can approve access to data? Who can view logs? Who can restore from backup? Who can change encryption settings? In on-premises environments, the organization often controls more layers directly. In public cloud, control is exercised through provider consoles, identity systems, policies, and service settings. In hybrid environments, control can become fragmented. Strong governance makes these control points visible so people do not assume protection exists where no one has actually configured it. Scalability is one of the reasons organizations adopt cloud services. Scalability means the ability to grow or shrink resources as demand changes. In an on-premises environment, scaling may require buying hardware, waiting for delivery, installing equipment, and planning space, power, and cooling. That can take time and money, but it may provide predictable control. In cloud environments, scaling can often happen more quickly because resources are available from the provider's larger pool. That can help with seasonal demand, new applications, disaster recovery, analytics, or sudden business growth. Security has to scale too. More resources mean more identities, more logs, more configurations, more data movement, and more possible exposure. If cloud resources can be created quickly, insecure resources can also be created quickly. Good architecture makes secure patterns easy to repeat as the environment grows. Cost looks different across these models. On-premises environments often involve large upfront spending for hardware, facilities, licenses, and staff, plus ongoing costs for maintenance, power, cooling, replacement, and support. Cloud often shifts spending toward usage-based costs, subscriptions, and service consumption. That can help organizations avoid buying capacity they do not always need, but it can also create surprises when usage grows, data transfer increases, or unused resources are left running. Private cloud may require significant investment because dedicated capacity and specialized management can be expensive. Hybrid environments may carry costs from both worlds at the same time. Security costs are part of the picture. Monitoring, backup, encryption, identity management, audits, training, and skilled staff do not vanish in cloud. A cheaper architecture that creates hidden exposure may become expensive later through incidents, downtime, compliance problems, or rushed redesign. Risk changes with each architecture model. On-premises risk may include aging hardware, limited staffing, local disasters, patch delays, physical access issues, and difficulty scaling quickly. Public cloud risk may include misconfiguration, over-permissive identities, exposed services, provider outages, data residency mistakes, and lack of visibility into provider-managed layers. Private cloud risk may include high cost, complexity, and overconfidence in dedicated infrastructure. Hybrid risk may include inconsistent controls, weak integration, duplicated identity stores, unclear logging, and exposed connections between environments. Community cloud risk may include shared governance challenges and dependence on requirements that may not fully match your organization. None of these models is automatically safe or unsafe. The safer choice is the one whose risks are understood, accepted, monitored, and controlled. Security architecture is not about choosing the newest model. It is about choosing the model that fits the mission and then protecting it honestly. Data location and data movement are also central to architecture decisions. Some information may need to stay within a certain country, region, facility, or legal boundary. Some applications may require low latency, meaning they need fast response times because delays affect safety, user experience, or business operations. Some systems may need to work even when outside connectivity is limited. On-premises architecture may provide strong local control, while cloud architecture may provide easier global reach. Hybrid architecture may keep sensitive or latency-sensitive systems local while using cloud for less sensitive workloads or broader access. Public, private, and community clouds may offer different options for where data is stored and how it is protected. From a security point of view, you need to know where data lives, where it travels, who can access it, and what controls follow it across boundaries. Architecture models also affect resilience and recovery. Resilience means the environment can keep operating or recover when something fails. On-premises resilience may require redundant hardware, backup power, alternate sites, tested backups, and careful planning by the organization. Cloud resilience may use provider regions, availability zones, managed backups, and automated recovery options, but those features still need to be selected and configured. Hybrid resilience can be powerful when one environment supports another, but only if dependencies are understood. A cloud application that depends on an on-premises identity service may fail if the local connection is down. An on-premises recovery plan that depends on cloud backups may fail if access controls or network paths are broken. Security architecture should consider failure before failure happens. Recovery is not just a technical feature. It is a design choice that must match business expectations. Architecture models shape who does the work, where controls sit, and how risks are managed. On-premises environments give strong direct control, but place heavy responsibility on the organization. Public cloud offers flexibility and scale, but demands careful configuration and identity management. Private cloud offers dedicated use, but still requires disciplined operation. Hybrid environments reflect the reality that many organizations live in more than one model at once, which makes consistency and visibility critical. Community cloud supports shared needs among similar organizations, but still requires clear governance and responsibility. As you study these models, keep comparing ownership, control, scalability, cost, resilience, data location, and risk. The right architecture is not the one with the most impressive name. It is the one whose responsibilities are understood, whose controls match the data and mission, and whose design can be operated securely over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.